This is our first of our differential equations videos for A-level further maths. We're going to look here at how we can separate the variables. So we're going to be looking at finding the general equation of the first order differential equation in which the variables are separable. Right, first of all, this thing, first order, means it's going to have a dy by dx. If it had been second order would involve d2y by dx squared. So a first order differential equation involves just dy by dx. Okay, so if you're in this situation here, where you've got dy by dx is equal to a function of x times a function of y, so f of x times g of x, then what you can do is separate the variables. So if you brought this g of x across to the other side, what you will have is 1 over g of x times dy by dx is equal to f of x. So you've got a function of y effectively times dy by dx is equal to a function of x. And then this is where the magic happens. This is separating the variables. So if you can imagine, I know this doesn't mean that dx is dividing by dy, but just to keep it really simple, if you multiplied across by that dx, then you would have 1 over g of y dy is equal to f of x dx. And then that's mathematical nonsense what I've done, but if you put an integration sign then around it, it makes sense. So that's how we're arriving at this line. So that's what I'm really thinking as if I'm doing, even though I know I'm not. I'm multiplying across by that dx. So then you'll have f of x dx, 1 over g of y dy is equal to f of x dx. That's mathematical nonsense really, but if you put the integration sign around it, it makes sense. So, and you can see here, I've got a plus c. I've only put it on one side, and that is it. Okay, we're going to look at an example here, just one example of how we can use this, separating the variables. So it says, given that y is equal to 2 at x equals 0 and dy by dx is equal to y squared plus 1, find y in terms of x. Right, we were hoping that we would have dy by dx is equal to f of x times g of y. And it doesn't seem like we're in that situation. So what we have to do is manipulate it a little bit. So we're going to rewrite our dy by dx as y squared plus 4 upon 1 just. Okay? So then you can see it is in that form. You've got a function of y times 1, and 1 could be a function of x, it could be a function of anything you want it to be, but we're calling it a function of x. So that's what we've got. So what we're going to do, I'm going to bring out 1 over y squared plus 4, it's now across the other side, times your dy by dx is equal to just 1. And then we're going to separate our variables. So really what I'm thinking of, I've got 1 over y squared plus 4 times my dy is equal to 1 times my dx. That's obviously not what that dx is doing, it's not multiplying. But if you put an integration sign around it, it makes sense. So we're going to be, we have separated the variables, and you can now integrate. Okay, we'll do the right hand side first because it's easy. Integrate 1 with respect to x, you get x plus your constant of integration. And on the right hand side, if you use your formula booklet for this one, if you look up the integral, I think it comes up as the integral of 1 over x squared plus a squared. I think that's what it comes up as, is 1 over a tan to the minus 1 of x over a. I think that's the form it's in. So here, your a would be 4. When you're integrating 1 over y squared plus 4, your a would be 2, I should say. So this is going to be 1 over 2 times inverse of tan of y over 2. And that's it. Okay, we'll go on from here. It tells you another wee bit of information. It tells you when x equals 0, y is equal to 2. So we'll just write that down. X equals 0, y equals 2. So we'll just put that in. That means a half of tan to the minus 1 of 2 over 2 is equal to 0 plus c. 2 over 2 is just 1. Tan to the minus 1. And remember, you're using radians here. So tan to the minus 1 will be pi over 4 is equal to c. So your c works out to be, that's going to be pi over 8. Okay. And then we'll go on from there. That means what you've got is a half tan to the minus 1 of y over 2 is equal to x plus pi over 8. and we want to make y the subject. Does it ask you? Yeah, it says find y in terms of x. So we want to make y the subject. Right, there's three things going on here. First thing is your y is being divided by 2. The next thing, you're doing the inverse tan of it. And the last thing you're doing is you're multiplying by half. So the reverse of multiplying by half, opposite of multiplying by half, is dividing by half, which is the same as multiplying by 2. So you just have tan minus 1 of y over 2 is 2 times this. It's going to be 2x plus pi over 4. Next thing we have to reverse is an inverse tan. So just have y over 2. Opposite of inverse tan is just tan. Tan of 2x plus pi over 4. And then my last thing, multiply it all by 2, squeeze that on, and then that's just going to be 2 times tan of 2x plus pi over 4. And that's it.